The Excel payment function, or PMT, is useful for identifying payments given certain scenarios. The syntax of the payment or PMT function is akin to the present value, future value, where you enter for rate, number, periods. In this one, we can enter for both present value and future value, as well as type. If you've watched the present value, future value, you should be already familiar with this. When it comes to arguments such as rate, number of periods, we either need to divide by the number of subperiods or multiply. And typically, when we are looking with a present value to get a future value amount, we will treat the present value as a cash outflow and the future value as an inflow. And so Excel will recognize typically the payment as also an outflow being made. So the way we set this up is to identify that the present value is an outflow at time 0. So we have two sample questions here. The first one is very practical. Let's say you plan to retire in 20 years. You've saved $175,000, and you determine to retire comfortably you need $1.25 million. You can earn an average return of 12% compounding monthly. How much do you need to contribute to your savings each month to retire? So what we'll do is we'll use the PMT function and then just double check using the future value to make sure that our payments are right. So we'll start with =, PMT. If we hit tab, we see that we're prompted with the syntax of the payment function. We know that the rate was 12%. We have to divide for the subperiods to get the periodic interest. We then move to periods. We know 20 years with 12 subperiods. Again, we want to treat the outflow or cash flow at time 0 as an outflow. And our future value is what we expect to get in 20 years. And the question is not giving us any information to think that the payments, that is the savings contributions at the beginning of the month, so we'll enter 0 to indicate that the monthly contributions at the end of the month. And really quickly see any mistake. Okay, there we go. So we see that we'll need to contribute $663.32 every month, giving this rate of return in the present savings to have a total amount of $1.25 million in 20 years. We can check this by using the future value function. We know our rate, our number of periods, we have the payment. Now we can also indicate the payment is negative, or we could, but then PV positive. Let's just leave it as the way it is. Our present value, our outflow at time 0 will be negative, and the payments received at the end of the period. And so you can see we've saved $1.25 million. So we know for a fact that we need to save $663.32 every month, contribute to the savings. It's getting 12% compounding monthly to reach our funding goal. The next scenario is you want to buy a house using a 15-year mortgage. So what we're looking at is you know how much you approximately want to spend today. There's a cost in time. So you want to use a 15-year mortgage, and that tells us the number of years. The prevailing rate is 3 7/8. The median home price in the neighborhood you want to live in is $225,000. So that gives us the present value for the loan. How much will your monthly payments be? So we know we're dealing with months, so we'll do 12 for mortgage, and we don't need to enter anything for future value. So we'll start off again with the PMT function. We'll reference the rate. and we need to account for the periodic interest. Number of periods is 15 years. We multiply by the number of subperiods. Of course, we're going to make a purchase price today, so that's going to be a cash outflow of $225,000. The future value, 0. And payments are made at the end of the month, so 0. And so what we see is if we want to buy a home today with no money down, we would have to make a monthly payment of $1,650.24. Now we could approach this from a secondary standpoint. We could say, well, what if there is money down? So let's say like a traditional mortgage, we're going to place 20% down. How much will our payment now be if we're putting 20% down? So our arguments will be mostly all the same. We'll start with payment, again the rate, number of periods, the present value, except times 1 minus the down payment, there's a future value of 0 by the time we pay off the loan, and the payments are made at the end of the month. Oh, we also need that $225,000 to be an outflow times 0. So if we bring 20% down, we see that our mortgage now would be $1,320.19. If we want to take this in further detail, we can break the payment down using two functions, which are known as the PMT function and the IPMT function. If we look at the PMT function, we'll see that returns the payment on principal. So that is, of this payment for $1,320.19, how much for each period is going to principal. So of course this is going to change from payment 1 to payment 2 to payment 3. And as we do the IPMT, this will give us the interest for each period. So we'll see as our loan amortizes how much of the payment is going to go to principal and how much goes towards interest. We'll cover this in deeper detail in the amortizing a loan tutorial video.